I welcome you all to my class. Today we will discuss few numericals on dynamics or the first part of dynamics, that is our rectilinear motion. Rectilinear. So in rectilinear motion we will discuss two parts. First, we can divide motion into three categories. That is, it is uniform velocity motion. I will tell few basics. After that, I will solve numericals. Uniform velocity motion, then uniform acceleration motion. In short, I'm writing acceleration like that. Then non-uniform acceleration motion. So we will solve problem on these two. In case of uniform velocity motion, we know simply our velocity is, or we write velocity as v is equals to distance by time. And for uniform velocity, uniform velocity, our acceleration is always equals to zero, because acceleration, because what is the formula for acceleration? Formula for acceleration is change into velocity by change in time. As the body is moving with uniform velocity, so the acceleration, there will be no acceleration. So we will find acceleration as zero. This is the case of uniform velocity. Then the case of uniform acceleration. Uniform acceleration. In case of uniform acceleration, we have what formula? We have few different formulas. What they are called as equations of motion. Equations of motion. So in case of uniform acceleration, our acceleration is equals to change in velocity with change in time. Or we can say final velocity minus initial velocity by time. And always remember, we generally denote v as final velocity and u as initial velocity, and time is represented by t. And what are the other most equations of motions? First equation of motion is equals to v is equals to u plus at, where v is the final velocity, u is the initial velocity, plus a and t. A is the acceleration or uniform acceleration, you can say. T is the time. Then the second equation of motion, S is equals to ut plus half at square. What is that? S is the displacement. U is again initial velocity. T is the time required. A is equals to acceleration. Then come to your last equation of motion, that is v square minus u square is equals to 2as. Basing on this formula, we will solve few numericals on uniform acceleration. Before that, always remember a conversion which is going to help you in between 1 kilometer per hour. How 1 kilometer is converted into 1 kilometer per hour is converted into meter per second, because you have to solve in same unit or meter per second. So you have to convert all the things in meter or second. So you need to convert kilometer per hour into meter per second. So 1 kilometer is equals to 1000 meter, and 1 hour is equals to 3600 second, which is equals to 5 by 18 meter per second. So 1 kilometer is equals to 5 by 18 meter per second. So you can calculate for x kilometer per hour. You can calculate it as x into 5 by 18 meter per second. So you can easily calculate for x kilometer per hour. You can convert it into meter per second. So we will directly go to our numericals without wasting any time. So we'll start with the easy one. A motorcyclist driving a vehicle with a velocity of 30 meter per second always try to mark the data given. Suddenly finds a child on the road 100 meter ahead. He applied brake in order to stop the vehicle within 10 meter from the child. Determine the retardation of the vehicle and the time required to stop it. Always remember, retardation is nothing but the negative acceleration. Retardation is the negative acceleration. If your acceleration is positive quantity, then a retardation is a negative quantity. When you get acceleration as negative and negative in terms of you get a negative value, it is called as retardation. So we'll again read the question. A motorcycle. A motorcycle is driving a vehicle with a velocity of 30 meter per second. The velocity is given 30 meter per second. Suddenly finds the child on the road 100 meter ahead. He applied brake in order to stop the vehicle 10 meter from the child. Determine the retardation of the vehicle and the time required to stop it. So what data is given? So the motorcycle was driving at 30 meter per second. So when the event happened, the motorcyclist was driving the vehicle at 30 meter per second. So initial velocity is 30 meter per second. You got the initial velocity. Then what happened in the next phase of the event? Suddenly finds a child on the road 100 meter ahead. He applied brake in order to stop the vehicle. Stop the vehicle is important thing. In order to stop the vehicle, as the vehicle is stopped, that means the final velocity is equals to 0 meter per second. As the vehicle is stopped within 10 meter from the child, that means he was initially he was ahead of 100 meter, but he will stop before 10 meter. That means when you will apply brake, how much distance you will cover? S is equals to 100 minus 10. That means 90 meter, which means When you will apply brake within 90 meters, you will stop, or you will stop at 90 meters. And with this, we have taken down all the data. That means we will calculate the retardation and the time required to stop it. So what is the retardation? Right now, let us answer using the third equation of motion. V square minus u square is equals to 2as. So you know v square is equals to 0. 0 square minus 30 square is equals to 2a. We need to calculate. S is 90. So minus 30 square is equals to 2a. I'm simplifying 30 for each of calculation so that you can calculate easily. Here this will cancel. So when you divide 30 by a is equals to minus 30 by 6, that is minus 5 meter per second square. So your acceleration is minus 5 meter per second square. Your retardation will be 5 meter per second square. Your retardation. That is the value of your retardation. And acceleration is equals to minus 5 meter per second square. For time, you need to put first equation of motion, that is v is equals to u plus 80. So your v is equals to 0, v is equals to 30 plus what is the value of a? Minus 5 t. So I am writing 30 minus 5t. When you will bring that 5t here, 5t is equals to 30. E is equals to 30 by 5 is equals to 6 seconds. Or generally, we never write the unit of second as SCC. We always write the unit of second as S. Okay. This we saw the first numerical on uniform acceleration. We will go to the next numerical, a bit difficult than this. So see here, a I think here it is care. It is not care. It is car. And a car driver traveling at a velocity of 72 km per hour observes a traffic light 300 meters ahead of him turning red. The traffic light is timed to remain red for 20 seconds. The driver wishes to pass the light without stopping the car as it turns green. Determine uniform acceleration, the speed of the car while it is passing the light. So what is given and what you need to calculate? Let us write the see in the starting of an event it is given 72 km per hour. That means it is initial velocity because the velocity before the starting of the event. That is the initial velocity. And I told you how to calculate this, convert this into meter per second. That is 72 into 5 by 18 equals to how much? 20 meter per second. 18 divided by 72 is 4. 4 into 5, 20 meters per second. So, what is happening? Again, I am repeating the question. Car driver traveling at 72 km per hour observes a traffic light 300 meter ahead of him turning red. The traffic light is timed to remain red for 20 seconds. So, the traffic light will remain red for 20 seconds. If the driver wishes to pass the light without stopping the car, just as it turns green, just the light turns green. So that means the driver has applied brake but he don't want to stop. That means he will have some velocity. He will have some velocity, that will be some value, some velocity at the traffic stop. That means he has traveled for how much seconds? 20 seconds. When the light was turned on, he was when the light was turned on, he was traveling with 20 meter per second. When the light was green, see means I mean to say that when the light was turned red, he was traveling at 20 meter per second. And when the light was turned green, he has a velocity v, which we will calculate. And the time taken was 20 seconds. So how much distance he covered? He covered the distance of 300 meters. Got it? Then what you need to calculate to determine the uniform acceleration and the speed of the car. See, from this you can easily say that as the driver has applied brake, so he must have reduced the speed. So the driver has applied brake. So we will calculate what will be the acceleration, means here retardation. Okay, let us calculate. So what data is given? U is given, T is given, S is given. We need to calculate V and A. So what first formula we will use? We will use the second equation of motion. That is S is equals to half, S is equals to ut plus half a t square. Always try to check what data is given and which formula it suits, so that you will easily get the unknown value. So we have S. I'm writing the here in order to save some space. 300 is equals to ut. U is equals to 20. T is equals to again 20 plus half a. We need to calculate t is equals to 20 square. So 300 is equals to 20 into 20, 400 plus half a. 20 square is 400. 200. So 200 a is equals to 300 minus 400, which is equals to minus 100. A is equals to minus 100 by 200 is equals to half or 0.5 meter per second square. That is the uniform acceleration. See, this is the uniform acceleration and it is in negative. That means the driver must have applied brake. So that is the retardation, which is equal to 0.5. Never get confused between acceleration and retardation. They are same things, but acceleration, negative acceleration is called as retardation. So what you will calculate right now, you have calculated the acceleration. You need to calculate the speed of the light at the traffic post or when the car will pass the light. So E is equals to U plus AT. That is, we will use for the first formula or first equation of motion. That is, V is equals to U is 20 plus A is minus 0.5 T 20. You will get something like this is equals to 20 minus 0 minus 0.5 into 20 minus 10. That is equals to 10 second equals to 10 into, as while converting into meter per second we are multiplying 5 by 18, but to convert into kilometer per hour you need to convert multiply 18 by 5, which is equals to 36 kilometer per hour. Okay, with this we have solved another problem of uniform acceleration. We will go to the next problem which has uniform acceleration, but that uniform acceleration is due to acceleration due to gravity. So we will solve that. Here the uniform acceleration is due to acceleration due to gravity. So this is our third problem. A particle is projected vertically upward from the ground with an initial velocity of 10 meter per second. Find the time taken to reach the maximum height and maximum height reached, time required for descending, and velocity. So what happened? A particle is projected from the surface. This is the surface or from the ground with a velocity of 10 meter per second. That means the particle has an initial velocity of 10 meter per second. Then what happened? It moved to a height. Suppose that is, it moved to a height that is h. It moved to a height h. At that point, it will be at rest for certain interval of time. Well, or a small instant of time, it will be at rest. After that, it will again come downward. It will again come downward with the velocity which we will calculate. See, While it is going upward, it has the acceleration as acceleration due to gravity, but minus means minus acceleration due to gravity. But while coming downward, it is having positive acceleration due to gravity. So let us solve. When a particle is projected vertically upward from the ground with an initial velocity of 10 meters per second, find the time taken to reach the maximum height. Maximum height reached, time required for descending, velocity with which it strikes the ground. So given is our initial velocity 10 meters per second. When it will reach this point, it will stop for an instant. So final velocity is 0 meter per second because it will stop for an instant and it will come back. So at that point of time, the final velocity is 0 and acceleration as it is going against the gravity. So acceleration due to gravity. But as it is going against the gravity, we have put a minus. While something is going upward, that means it is going against the gravity. So we will always have minus acceleration due to gravity. So which is equals to 9.81. So always remember whatever data given in the question, try to answer as per that. Some question in some question that is written that take g as 10 meter per second square. In some question they write take g as 9.8 meter per second square. Depending upon that you take. So here I am taking 9.8 for ease of calculation. So what formula we will use? This is the case of reaching the top or ascending. This is the case of reaching the top. So in reaching the top, what we will calculate? First thing, the time taken to reach the height. So we can use what data we have? We have u, v and a. We can use v is equals to u plus at. So easily we can calculate our unknown t from here. So v is equals to 0, u is equals to 10 minus as so let me write it minus as we have taken minus. So 0 is equals to 10 minus 9.8 p. 9.8 p is equals to 10. T is equals to 10 by 9.8. You can easily calculate this. On calculation, you will get approximately 1.02 seconds. That means the time required to reach the top is 1.02 seconds. So then the next part is we got the time. After that, maximum height reached. So what formula we need to put? We will put this s is equals to ut plus half 80 square. Our s is nothing but the h. U is equals to 10. T is equals to 1.02 plus half a is equals to So from this you can easily calculate h, and that will be somehow approximately 5.1 meter. So you do your own calculation, and after 5.1 meter it will reach the top. Once it reaches the top, the condition will be a bit different. So I'm doing another figure. It will start descending. It will start descending. That means at 5.1 meter, again the condition is at that point of time take the initial velocity as 0, and final velocity is the before reaching the ground. That velocity we will calculate. That velocity we will calculate. Then what distance it will cover? It will cover 5.1 meter. This is the case of descending. So for case of descending, our initial velocity becomes 0, and final velocity we will calculate. Acceleration due to gravity is equals to z, as it is going downward. That means it is not going against the gravity. That is why acceleration is positive. Meter per second square. So our distance covered is s is equals to h is equals to 5.1 meter. So what formula we will use to calculate the axle, to calculate the time? Formula we will use? You can use this formula. S is equals to ut plus half t square. So S is equals to 5.1 equals to ut, 0 into t. No need to write. You can directly write this 0. Half k is equals to 9.8 into t. We will calculate. So, your 5.1 equals to 9.8 by 2t square. T is equals to 2 into 5.1 by 9.8 square root. Square root of this. So again by solving we will get approximately the same value. We will get. Then after descending, what is its velocity with which it will strike the ground? So we will calculate the last part. We can use the simple formula or the first formula, that is v is equals to u plus 80. You know u is equals to 0 for the case of descending. So our v becomes 9.8 into 1.02. This is equals to 10 meters per second. That means it will strike with that velocity with which it was initially thrown upward, or with which it was initially projected. So let me zoom out so that you can get the answer in a single page. With this, you got the answer in single page, and this is the answer for a particle projected vertically upward from the ground with an initial velocity of 10 meters per second. So you calculate all the things: time required to reach the top, what is the height or what is the length to the top, time required for descending, and the velocity with which it strikes the ground. Okay, so then hope you all have understood the concept of constant or uniform acceleration motion, or if we can easily solve the problems related to uniform acceleration motion. Thank you. Thank you all. See you in the next class.